In this video, we're going to be talking about solving a system of linear equations given an augmented matrix. Okay, so this is going to be a three equations, so it's going to be a 3 by 4 matrix that we're looking at, and this represents x, y, and z, and over here are going to be our solutions. Now, what we're trying to do is get this to the form where it looks like this: 1, 0, 0 number, 0, 1, 0 number, and 0, 0, 1 number. Okay, that would mean that x is equal to that number here, and then y, the second one will be y is equal to that second number, and the last one will be z is equal to that third number. Okay, so you get ones on the diagonal, zeros everywhere else, and you have the solution for x, the solution for y, and the solution for z. Okay, so let's take a look at this. The first thing that we want to do is make sure that there's a 1 right here. And if there's not a 1 right here, you need to multiply by a number that will make that turn into a 1. After that, you want to use this equation, especially this 1 here, to get rid of this and turn this into a 0. So I need to multiply this 1 by something that will turn into the opposite of a 5. So I need to multiply that entire row by a -5. So I'm going to multiply by a -5, and then I'm going to add to this row. The top row is not going to change. Okay, so the top row is still going to be 1, 0, 4, 8. But now we're multiplying the top row by -5 and adding that down. So -5 times 1 is -5, and you add a 5, you get 0. -5 times 0 is 0, and 0 plus 1 is still 1. -5 times 4 is -20, and -20 plus 25 is 5. And then -5 times 8 is 40, or -40. And let's do that one in the calculator. So -40 plus 103 divided by 3. And let's change that into a fraction. So -17 over 3. Okay, and then the last one, nothing happened. -4, 0, -16, -32. Okay, so next I'm going to use this first equation, or this first row here, and try to get rid of this term. So the same thing I did when I was doing it to the first one, I want to get a 0 here as well. Okay, so what can I multiply 1 by so it'll be the opposite of -4? Well, I can multiply it by 4. So I'm multiplying this one by 4, and I'm going to add it to the third row. Okay, so the first and second row are not going to change. Okay, so you still have 1, 0, 4, 8, and 0, 1, 5, and -17 over 3. And then you multiply 4 times 1 and add to this. So 4 times 1 is 4, plus -4 is 0. 4 times 0 is 0, plus 0 is 0. And then 4 times 4 is 16, and 16 times, or 16 plus -16 is a 0. And then 4 times 8 is 32, and 32 minus 32 is a 0. So what happened here is that one of our rows completely disappeared. Okay, so what this means is that we are going to have a consistent dependent solution. Okay, so that's infinite solutions, and it's consistent and dependent. Okay, so how would I go about writing the solution if there are infinitely many solutions? And is there a way to represent that? Because when you say infinitely many solutions, you're not saying that every single thing is a solution. What it means is that there are solutions that fall under certain guidelines, and there's an infinite amount of them with those guidelines in place. It doesn't mean that everything is a solution. So I'm going to write these out as actual equations with x, y, and z and a number. Okay, so the first one would be 1x, or just x. There's not a y, plus 4z equals 8. And the second equation is there's no x, but there is a y, plus 5z equals negative 17 over 3. So notice in these two equations that we got from right here and right here that they both have z terms in them. So you have x with some z terms and you have a y with some z terms. Okay. So what I'm going to do is solve for x and then solve for y. So if I solve for x, I need to subtract the 4z, so that's equal to negative 4z plus 8. And if I solve for y, I need to move the 5z over by subtraction, so y is equal to negative 5z minus 17 over 3. Okay, so what we have is infinite solutions that fall on this line. X is negative 4z plus 8. Y is negative 5z minus 17 over 3. And z is just z. Okay, so what that means is that these are the stipulations for your infinite solutions. You pick any number you want for z, but then you figure out the other two numbers according to these stipulations. Okay, so let's try one. So let's pick z equals 1. Z equals 1. Okay, so we know z is equal to 1. To find the other two, x would be equal to negative 4 times 1 for z plus 8. Okay, so that would be 8 minus 4, so x is equal to 4. And then y, plug in here, would be equal to negative 5 times our z, which we chose to be 1, minus 17 over 3. Okay, so let's plug that in to the calculator. We get negative 5 minus 17 over 3. Okay, so that's negative 32 over 3. Okay, so one solution of this is 4, comma, negative 32 over 3, comma, 1. And you could find any number of solutions that you want. Just pick some starting number for z and figure out the other two, and you will have a solution. Okay, here we have another matrix. We want to first, to solve this new matrix, we want to turn this number into a 1. But luckily for us, it's already a 1. So if that's the case, you can use that 1 to get rid of this and make it a 0. So we just need to turn the 1 into the opposite of this number. So I need to multiply this one by 3 through this whole thing and then add it to that. Okay, so the top stays the same. It would be 1, 7 over 3, 0, and negative 28 over 3. And then this would become 0, because 3 times 1 is 3, minus 3 is 0. 3 times this is 7, because the 3's cancel out, so 7 minus 6 is 1. 3 times 0 is 0, so the second one doesn't change at all. And then 3 times negative 28 over 3, the 3 cancels, that becomes a negative 28. And negative 28 plus 27 is negative 1. Okay, and then the last one is 0, 0, 1, negative 4. Okay, so now that we have that, let's look at what we have. We have our solution for z right here because it's 0, 0, 1. So we know already that z is equal to negative 4. Okay, we also know that this is our y, so y is equal to negative 1. Okay, so we're almost done. We just need to solve this. So how I'm going to do that is get rid of this 7 over 3. To do that, I need to use this row. So I need to multiply this 1 by something that will turn it to the opposite of 7 over 3. So negative 7 over 3 is what I'm going to multiply through and then add to this. Okay, so the bottom two are not going to change. 0, 1, 0, negative 1, 0, 0, 1, negative 4. The top one is, so negative 7 over 3 times 0 is 0, so that's not going to change this one here. So that's still a 1. Negative 7 over 3 times this is negative 7 over 3. And when you combine it with a positive 7 over 3, it turns into 0. Okay. Negative 7 over 3 times 0 is 0. So when we add it here, that doesn't change. And negative 7 over 3 times negative 1 is 7 over 3. That's positive 7 over 3. So you get 7 over 3 minus 28 over 3. 7 minus 28 is negative 21 over 3, which is equal to negative 7. Okay, so this has been completed. Our solution is negative 7, negative 1, negative 4, or the ordered triplet of negative 7, -1, -4 for x, y, and z. Okay, let's look at this problem. It has 1, 0, -1, 6, 3, 1, -5, 69 over 4, and 0, -4, 8, 3. Okay, so the first step is to always get a 1 here, and since it already has a 1 there, we can move to the next step, which is to use that 1 to get rid of this and make it turn into a 0. So what would I multiply the 1 by so that it would turn into the opposite of 3? -3. So I will do that, and the top and bottom are not going to change. So it'll be 1, 0, -1, 6. But then I'm going to multiply -3 times 1 and add. So -3 times 1 is -3, plus 3 is 0. -3 times 0 is 0, plus 1 is 1. -3 times -1 is 3, plus -5 would be -2. And then -3 times 6 would be -18 plus 69 over 4. Let's do that. So we get -18 plus 69 over 4. And that is -3/4. Okay, and then we get 0, -4, 8, 3. Okay, the next step is to get a 1 right here, but we already have a 1 right there. If we didn't, we would just multiply by the fraction that would make it turn into a 1. Okay, but we're going to use it to cancel out this term here. So what do I multiply 1 by to get the opposite of -4? And that's going to be a 4. And I'll add it there. Keep in mind that the top and middle are not going to change. So you get 1, 0, -1, 6, 0, 1, -2, -3/4. Okay, so we multiply and then add. So 4 times 1 is 4, plus 4 is 0. 4 times -2 is -8, plus 8 is 0. And then 4 times -3/4 is -3. And then -3 plus 3 is 0. So we've got another one that is infinite solutions because the third one canceled out completely. Now, if we got something that would have had a number here, or a number here, or a number like over here or somewhere, and we couldn't get rid of it, then that would be a no solution problem. But when the entire thing goes to 0, it still has infinitely many solutions, and they can be written like this. So let's write the equation out. Remember, this is x, y, z. Okay, so 1x, or just x, minus z equals 6. And then we get y minus 2z is equal to -3/4. Okay, so notice that I have z's in both of these, but then an x in this and a y in this. Okay, so we're going to solve for x and solve for y and put them in terms of z. So all I have to do to this one is add the z to both sides, and I get x is equal to 6 plus z, or z plus 6, however you want to write it. And on this one, I add the 2z to the other side. So I get y is equal to -3/4 plus 2z. So I can write my solution as, it'll be x, y, z, right? But our x is 6 plus z. Our y is -3/4 plus 2z. And our z is just z. Okay, one more bonus problem because we didn't get to a inconsistent system. So let's look at this problem. So the first thing to do is make this turn into a 1. It already is. Okay, the second thing is to use that to cancel out this one and turn it into a 0. So what do I multiply 1 by to make it the opposite of a 1? Well, -1. So -1 and add. So the top doesn't change. That's still 1, 1, 1, 1. But -1 times 1 and then plus 1 is 0. -1 times 1 is -1, plus 2 is 1. -1 times 1 is -1. 4 minus 1 is 3. And -1 times 1 is -1, plus 2 is 1. And then the bottom stays the same, 0, or 2, 0, -4, 1. Okay. The next step is to get a 1 here, but it already has a 1 there. Okay, so we don't have to mess with that. So I can use this to make this turn into a 0, which it already is. But I need this to be a 0 as well, so let's use the top equation to make this 0. So what do I multiply 1 by to turn it into the opposite of 2? Well, -2. So I'll multiply -2, and I'm going to add it to that bottom row. Okay, the top and middle row are going to stay the same. So 1, 1, 1, 1, 0, 1, 3, 1. And now we look at the fourth one. So notice that -2 times all these are -2. Okay, so each time I multiply, I'm going to get -2. So -2 plus 2 is 0, which is what we wanted. -2 plus 0 is -2. -2 plus -4 is -6. And then -2 plus 1 is -1. Okay, so now I need to get rid of this using this equation. So what can I do to change this into the opposite of -2? Well, I'll just multiply it by 2 and add. Okay, so the top and middle one will remain the same. 1, 1, 1, 1, 0, 1, 3, 1. And then 2 times 0 is 0, plus 0 is still 0. 2 times 1 is 2. Add that to this and you get 0. 2 times 3 is 6. Add that here, you get a 0. And then 2 times 1 is 1, minus 1 is 1. Okay, so we have a problem here. We've canceled out all our variables, but we've still got a number. So this is like saying that 0 is equal to 1. Okay, because you don't have any variables, so the left side of the equation is 0, and it's equal to 1, which is not true. That's false. Okay, so once you get into this part of the problem where there's a number over here, but all the rest are zeros, then this is done. This is a no solution. And it would also be called an inconsistent system. No solution. And that's it.